Hello, my name is Jordan Hasty, and I'm working with Carlos Guerrero, and this is our project on MorDNN. MorDNN, which stands for Mordhau Deep Neural Network, is a deep neural network that learns to play the game Mordhau, which is a skill-based competitive melee sword fighting game, and it learns to play the game by replicating human play styles. Mordhau features a complex combat system, and MorDNN demonstrates its intelligence through complex, dynamic behaviors that are indistinguishable from human players by making decisions within a continuous state and action space. Additionally, the creation of this project introduces a unique method for creating advanced AI for real-time games. The goal of this project is to develop an advanced AI for the game Mordhau, which presents many unique challenges. So the first challenge is that defeating an opponent in Mordhau is not a straightforward task. To defeat an opponent in Mordhau, it requires you carefully analyze your opponent's movements and that you execute a series of movements to outplay and sometimes outsmart the opponent. And usually fights in Mordhau involve a lot of mind games, such as trying to provoke certain actions from your opponent. Another challenge is that in this game there are no discrete attack actions, in contrast to some other games like For Honor, and all attacks are subject to manipulation in real time. Typically, creating an AI that learns to play games involves reinforcement learning. However, in this case, it's not feasible. In order to apply reinforcement learning, it would require simulating the gameplay and simulating it fast enough so that an agent could learn in a reasonable amount of time, which would take massive amounts of computing resources. Additionally, the goal of this project is to create an AI that plays like a human and not superhuman level. Another challenge for creating an AI for this game is that Mordhau is not open source, and the creation of an effective AI requires data that cannot be obtained without interfacing with the game process. So the motivation for this project is to create an AI that's capable of playing with human-level performance within a real-time continuous state and action space. And some of our research questions are how to utilize machine learning to create an AI capable of human-level performance, and how to collect data from the game, interfacing with a non-open source process. So going over the machine learning aspect of this project, MorDNN utilizes a deep LSTM network that's trained through supervised learning on data provided by human players. And the neural network is comprised of stacked layers of LSTM nodes and dense layers. And our current model has about 4 million parameters total. Also, we use Python and TensorFlow to create the neural network. So because Mordhau uses both discrete and continuous actions, we utilize a branching structure to separate the output layers for binary and analog outputs. So because of this, the overall loss function is a combination of mean squared error and cross entropy loss. So the neural network learns by being given the game state at the current time step t, and the game state at that time consists of the bone positions of the enemy, such as their head, foot, hand, velocities, and all these vectors are calculated relative to a coordinate plane that's centered on the AI, and with the y-axis intercepting the opponent's position, which allows the neural network to learn more easily. So given all this information, the neural network then attempts to predict which movements to make at the time t+1, which are executed 20 milliseconds later. Now going over our process interface, which collects data and executes the AI in-game. The data is collected using a game process interface, which records the data as you play, and it's developed in C++. To load the interface into the game process, we use DLL injection to read process memory using Windows API functions. And the interface uses the game's dissected data structures to find memory addresses to read from. The process interface also executes the neural network using the parameters generated after being trained in Python, and the outputs from the neural network are sent to the game through emulated keystrokes and mouse movements. So the training process utilizes the data collected from the process interface, and the data is recorded as a sequence of game states and player outputs at 50 Hz, and it's trained on sequences of varying length from 3 to 8 seconds. So at each time step in a sequence, it consists of the game state as input features, the binary outputs like the buttons being pressed, and analog output, which is the pitch and yaw relative to the enemy. So the AI is able to achieve human-level performance against certain opponents, giving only 24 minutes of game data, and training for less than 1 hour on the hardware listed. So going over the results, the performance of the AI is difficult to represent numerically, so we've just relied on observation of the performance. And through testing, human opponents can't discern whether their opponent is a human or the AI. And at the end of this poster presentation, there will be video showing the bot performing in-game. The creation of MorDNN explores and solves some of the problems that come with trying to create advanced game AI. So our project creates an AI that performs within a continuous state and action space, and the training method of this agent is much more time effective and computationally efficient than reinforcement learning, as it avoids having to simulate the game and player agents. It also solves the challenge of creating a game AI that performs at human level, yet does not perform on a superhuman level, which creates a more ideal opponent for human players. And we believe this project creates a broader impact by demonstrating the methodologies used so that more ideal AI opponents can be implemented by game developers. Thanks to MorDHA's lead developer, Marko Grgorovic, for approving the creation of MorDNN. You can check out the project on GitHub or contact us for more information. So that's the end of our poster presentation, and we'd like to thank you for watching. If you'd like to see more, you can continue watching this video. Next we'll show how MorDNN performs in-game. This video shows the perspective of the AI fighting against me. It should be noted that I've been playing this game for over 3 years, so I have a lot of experience, which gives me a big advantage over the AI. The rest of this video just shows some annotated clips explaining some of the gameplay.